Decided to build a lap counter, nothing fancy, something that counts laps. First, the reflective photo transistor. The infrared LEDs on one side, the photo transistors on the other. I connected an LED so I could see if anything happened. It looks like something happens, so I needed to add a counter. The 4017 decade counter is about as basic as you can get. You just follow an LED. I plugged the output of the sensor into the input of the 4017. Nothing happened. So what if I remove the LED and use a transistor to amplify the current? I added a 10K resistor and moved the output of the sensor to the collector, the transistor there. And let's try again. Let's see if we can get this thing to count. It counts. So let's embed it into the racetrack and see if it counts the car. There's the sensor. Yeah, it counts. It counts a lot. I think I want that lane, right? So it's back to the old drawing board. Let's add a Smith trigger. That should smooth the circuit, keep it from counting the noise. There's the 555 timer. Configured the Smith trigger. Even added an RC circuit. I'm not really sure I'm debouncing anything. Shoot, more double counts. So I think I need to slow the pulse. So let's add a 555 timer configured as a monostable circuit. There's the monostable circuit. I used a 10K resistor and settled on a 33 microfarad capacitor. I tried a 10 microfarad first. Worked okay. 33 slowed it a bit more. Either one would probably be fine. Notice LED signal is inverted, and now it comes on when it counts. But let's try it. Oh, that's solid. That's solid. All right, the second circuit I wanted to try was the little slot counter. I think they call them transmissive phototransistor optical switches. Here's what a little slot counter looks like. This one is too big. I don't think it could count an HO size guide pin. Let's put it against the car and we'll see how it looks. Nope, that pin doesn't go in far enough. So we need a smaller sensor. So this one looks like it might work here. It is, let's measure it. Let's see how deep it is. It's probably on the data sheet, but let's see, that's about 4.5 millimeters deep. All right, so how long is the guide pin? The guide pin's about 3 millimeters long. So the data sheet says the optical axis is about 1.5 millimeters, so that might work. This is the same circuit we used before. I had to change the resistor values a little based on the data sheet. I used a 1K resistor and a 10K pot. Wires a variable resistor. And let's see if it'll count. I just use a little screwdriver. Oh yeah, it counts. Counts pretty good. So the third circuit I wanted to try is an infrared LED and photodiode. We'll configure that with the tried and true light bridge. That's the photodiode I used, and there's our infrared LED. I used an op-amp LM324 configured first as a transimpedance amplifier and then as a Smith trigger. I think you also configure an op-amp as a monostable circuit to slow the pulse, but that looked over my head, so I used the 555 timer for the monostable circuit. So let's see if it counts. I'll just use the ruler for that, and let's pick that up and see. It counts. So let's solder together 3 circuits so we can test them. The first one we talked about was a reflective circuit. Next is a transmissive circuit. And then finally the photodiode circuit with a light bridge. So let's go racing. So in reverse order, we first have the photodiode circuit. By the way, I added a 500K pot. I notice the circuit is a bit sensitive to ambient light. The test track is sitting under a window with plenty of sunshine at different times of the day. I've been better to point the photodiode down. Might have been better to point the photodiode down and the infrared LED up. It works well though. I added a little oscillating 555 circuit that latches with an SCR to signify the winner. I think I can add a relay between the power pack and the track that turns the track off when somebody wins. I might do that. Next is our little slotted optical switch. If this counts that guide pin, I'll be amazed. There's a sensor. Nothing happened. Darn it. I had hope. I had hope. I think the pin is too small. Let's put a piece of masking tape on that. What do you think? There. All right, let's see if that counts. It works. So it's probably a good circuit for larger cars, but not for an HO car. So next is our reflective circuit. There's our sensor there. I like it. I might use this one on the big track. In fact, let me test it with an up-down counter with a relay. So I can preset the number of laps, and the relay turns on the oscillating circuit when the laps are done. Finally, here's the circuit diagrams.